Hello! .NET Core and NET6 become the main frameworks for developing applications in C# and VB.NET, and naturally SOLIDWORKS API developers who have their application written in C# and VB.NET targeting .NET Framework asking themselves, should they upgrade their applications to target .NET Core or even NET6? In this video we will talk how to create add-ins for .NET Core and NET6, what are the limitations, and should we upgrade our applications to those frameworks. SOLIDWORKS add-ins running in the same process and in the same application domain of SOLIDWORKS, which means that if there's multiple add-ins installed, they may share some common libraries. So we will also talk about DLL conflicts in this video. So let's start. In this SOLIDWORKS session, I have two SOLIDWORKS add-in in .NET Framework. Those add-ins are using the same framework, xcut.net, and they show in the Property Manager page with a text box which corresponds to each version of this add-in. So let me show you the source code of this add-in. So here's the source code. So if you've been developing SOLIDWORKS add-ins and Property Manager pages, you may notice that this code is quite short. This is because it is using xcut framework, which simplifies this development. It is a free and open source framework, and you can find more information about it by following the link in the description of this video. So as you can see, there are only standard assemblies referenced to this project, and here's the SOLIDWORKS xcut package. Same with the second add-in, so I just changed a couple of nodes and also the GUID of our add-in so they can run together. So here I have a shared library. We just have a test service which displays a message box. And here I have a version for this package, and also you can see my output directory using the version to output the DLL. So let's compile the version 1, so you can see it has been output to corresponding directory 100. So let me copy this path and add the reference to this DLL in my first project. Okay, so I can just click browse. Okay. So now let's go ahead and modify something in this shared library. So let's change the message box to show the version 2, and also let's change our version here, and we can now rebuild our shared library. So now that goes to the second folder. So my first library is still available. So let me copy this path and now add this into my second add-in. So now those two add-ins are going to use the same library but of different version. So we can just confirm that by expanding the assembly node, and you can see the version of this DLL is 2 and the version of this DLL is 1. Okay, so now let's rebuild that to make sure that our project is still built. Okay, both of them were rebuilt. Now let's go ahead and add the piece of code to display the message box by invoking the method of our service. So I'm just going to add another button in my toolbar, so it's quite easy with xcut.net. You just need to add new enum value and just handle that in our onCommand-click handler. So I'm just going to create a new instance of our test service. I will need to import namespace and just call the method which is going to show the message box from our service. So when user clicks the say hello button from the menu, this service will be invoked and message box with the corresponding version will be displayed. So let's repeat the same process for our second add-in. So note, because our second add-in is using the second version of this DLL, I expect that the first add-in will show me the version 1 of message box, and the second add-in will show me the version 2 of message box. So let's rebuild our add-ins and make sure they are still building correctly. So you can see there is no compile error. And now we can run SOLIDWORKS and test this functionality. SOLIDWORKS is now loaded, so we can try and invoke this command and test the functionality. So let me navigate to Tools, and let's go to menu of first add-in. So there is a say hello button, and you can see it displays the correct message. So let me click the second one. And you can see it displays the same message, so it is not displaying the version 2. So now let's try to understand why that happens. So the first, I would just make sure that it's still using the right version of DLL. So let me just copy the output path of my second add-in, and let's open some ILView or something like ILSpy, and I can just navigate to this folder, and I try to open the shared libraries in this folder. So you can see it displays the version 2, which is correct. So let's just repeat the same for the first version. So I'm just going to change this to 1 and import that library here. and you can see it's 1. So it's indeed using the correct versions. But it is not clear at this stage why it happens. So let me attach to SOLIDWORKS process so I can see the modules currently loaded in my application domain. So I just need to attach to SOLIDWORKS.exe. Now, when I've done that, I can navigate to the debug menu in Microsoft Visual Studio, and under the Windows, I should see the modules, and here's all of my modules loaded to application domain. So let's select the shared lib, and you can see it's only one library here, which is version 1. And I just want to point your attention, there is an up domain called default domain, so I'll be using that information later in the video. Based on this behavior, we can say that it is only one version of the DLL could be loaded simultaneously into the same application domain. And I'm just going to put a big asterisk on this quote because we're going to discuss it a bit later, and I will explain why it is not always the case and what needs to be done to override this behavior. When we changed the value of the message box in our shared library, we introduced what is called non-breaking change, which means that despite our message box is incorrect, both of our add-ons still work. Now, what would happen if we introduce a breaking change? So let's add a parameter to our sayHello method and just use this parameter in our message box. So let me rebuild the shared library. Because our first version of the add-on is still using the version 1 of the library, I can safely rebuild that project, and you can see I will not see any error because that library is still using the method without the parameter. But if I try to rebuild my second add-on, it will obviously display me the error, a compile time error, and I need to supply the parameter here. So let me just do that. And now I can just build it safely. So now that project compiled successfully. And let's run SOLIDWORKS and see what will happen. Now let's run this command and test the behavior. So we'll start by running the first version, and message box is displayed as expected. So let's try a second one, and you can see no message box displayed. So that means there was some error inside that code, which obviously threw an exception and our code did not execute. Depending where this code, you might have a different behavior, something like command does not invoke, non-handled exception, error, or even a crash of SOLIDWORKS. So is there a solution for this problem? Or I should always update and make sure that all of my add-ins running the same version of the shared library? Fortunately, it is. So let me just remove all of the shared libraries from my two projects and continue my demonstration, and I will answer that question. I already removed the libraries, so I now just need to remove the code which I have added, and also do the same in my second add-in, and also remove that command from here. Now I can try to build. Oh, I have an error of some namespaces. Obviously I need to remove those as well. So now I can build. So I have successfully reverted those changes. Now, in the beginning of my video, I mentioned that both of those add-ins are based on XCAD.NET framework, and framework is essentially the same as my shared library. So this just comes from NuGet and developed by Xarial, but the point is it's still a DLL which is used by your add-in, and it should follow exact same logic as your shared library. Currently, both of those add-ins are running exact same version of XCAD.NET, so you don't have any conflict. But let's go ahead and upgrade one of our add-ins. We have recently released a preview version of the next version of XCAD.NET, so you can just click include pre-release and upgrade that version here. So let me select that package and click update. So the second add-in is now using the preview version of XCAD.NET. So you can see there are a few breaking changes in this version, so I'll need to modify my code so it does not break. So firstly, that on configure services, which allows you to configure your dependency injection services, has been changed to protected, and also the signature of add method has been changed. So now we have fixed that problem, and we can now successfully build our add-in. So essentially we have the same issue we had with our shared library before. So first add-in is using different version, and second one using a newer version, and obviously it has a break and change, which we have modified. So you can see that we can select that DLL, and you can see that it is using 0.8.0 preview, and DLL here is 0.7.12. So now let's start SOLIDWORKS and test this behavior. So I might expect similar behavior, but you can see those add-ins loaded correctly, so there is no error at this stage. So let's open Property Manager page. So there is a 1 in the first page and 2 in the second. So both of them work correctly. You now think, okay, maybe that function which is on configure services just never called, that's why we don't have this problem. So you can see this function registered our logger. So we can just test whether our logger is successfully registered. So I'm just going to use debug view Microsoft tool to capture logs, to capture traces. So we can just include the xcard for our log. And let's just go ahead and click to commands and see what will be output into our log. So let's go to tools. Second one, click show property page. So you can see there is an entry in the log from add-in 2. And let's open this first one. And now you can see there is an entry from add-in 1. So those indeed work correctly. So there are 2 versions of this DLL seems to be loaded correctly. So let's go and open attach to SOLIDWORKS and see what our modules here. Okay, so let me filter to xcard SOLIDWORKS, and you can see there are now 2 DLLs with 2 different versions in the same default domain, application domain. So what is the difference between those DLLs and DLLs of my shared library? And to test that, let me copy that path and use my ilspy tool and load this DLL, and we'll try to find what actually is the difference. So I loaded first one, and let me load second one. Okay, copy and open it here. Okay, so now if I look at those DLLs, you can see there is a public key token assigned to both of them, but there is none in shared library. So this one is the main difference. So the public key token is generated when you strong name your assembly and sign it with a certificate. When you do that, framework can load many versions of the same DLL simultaneously into the same app domain, and thus resolving this DLL conflict. So now I should rephrase the original statement and say framework cannot load more than one version of the DLL into the same app domain unless they are strong named. I will not be covering the topic of how to strong name your assembly in this video, but you can just Google that, it's pretty simple. In the next part of the video, we're going to talk about SOLIDWORKS add-ins in .NET Core and .NET 6. xcard.net is compatible with .NET Framework 4.6.1, .NET Standard 2.1, and .NET 6.0. But it also has multiple computed frameworks, so you can use it pretty much everywhere across .NET ecosystem. You can read about compatibility and how to configure that framework to work with .NET Core and .NET 6 directly in the README from the NuGet or from xcard.net site. But there is one interesting note from Microsoft regarding the strong naming. So let me activate that tab, and it explains what strong names are, and it essentially what we just discovered in .NET Frameworks. It allows you to load multiple versions of the same DLL into the same app domain. But this article has a note that's saying that it does not work the same way for .NET Core or .NET 5+. So does it mean that we cannot use different versions of the same DLL for .NET Core or .NET 6 in our SOLIDWORKS add-in? So let's do a test and find out. Let me go back to my solution, and in the first step I will just clean the .NET Framework add-in. So when you do clean solution in xcard.net, it will automatically unregister your add-in from SOLIDWORKS. So now let me expand .NET Core folder. So it has similarly 2 projects. So now it has the same structure but just display different message. So it now telling me that this is a .NET Core add-in with a property manager page. So it also using the .NET Core target framework, and you can see it's using different version of package reference for xcard. So similarly to previously, one is using the preview version and the first one is using the currently public version. So if I would expand the libraries, you can see that it is picking up from a different directories. So this one is from 0.8.0 and another one is from 0.7.12. Okay, so now we can just rebuild this project. So similarly to .NET Framework, Xcode will automatically register the DLL in the add-in. So if you're using the standard libraries of SOLIDWORKS, you'll need to do some additional steps. So the registration process in .NET Core and .NET 6 is slightly different to .NET Framework, but again, Xcode would take care of that. So now we can activate part, and let's just go ahead and Tools menu and click the command. As you can see, both of our add-ins loaded and they display correct message in the property manager page, so both of them work. Let me activate the modules command. For that I need to attach to SOLIDWORKS process firstly. So it's clearly working the similar way of .NET Framework. So it already has a filter, and you can see we still have two versions of the same DLL loaded alongside. But I just want to point your attention that app domain name is now called CLR libhost. So previously it was a default domain, but it's still loading correctly, which is very promising. Similarly to add-ins developed in .NET Framework with Xcode.NET, when you clean the solution, it will automatically unregister the add-in from SOLIDWORKS. So let's complete our video and do a test for .NET 6. So in a similar way, I have an installation for Xcode with a different version. So in this case I'm using two preview versions, but of a different version. For first one is 4.2.9.6 and second one is 4.2.9.7. So target framework as NET 6.0 Windows. I have rebuilt it, so the add-in is registered. Let me start SOLIDWORKS and make sure that this works. But if .NET Core works, I expect .NET 6 to work in a similar way. And it indeed works correctly, so I have two different property manager pages with two different text boxes. So let me also attach to SOLIDWORKS process and inspect the modules. I can use the reattach command to make the process easier. So you can see there are also two versions of the DLLs loaded alongside each other, and they're also loaded in the same application domain as our .NET Core, which is called CLR libhost. Because both of the assemblies for .NET Core and .NET 6 are loaded in the same application domain called CLR libhost, while the .NET Frameworks are loaded into the application domain called default domain, I believe that it means that the assemblies of .NET Core and .NET 6 won't be compatible. So we can test that. So let's just build our solution to build all of our add-ins and see whether all of our 6 add-ins loaded into SOLIDWORKS. Now, while SOLIDWORKS is loading, from the splash screen I can see that it is attempting to load the .NET Framework add-in, .NET Core and .NET 6. Let's see if it will be successfully loaded into the SOLIDWORKS session. And now when my SOLIDWORKS is loaded, I can activate Tools menu, and you can see there are only .NET Core and .NET Framework versions of the add-in. And this is expected because, as we mentioned before, .NET Core and .NET 6 using the same application domain to load the assemblies. And even though Xcode.NET versions of the DLL are the same, but they're actually different DLLs because it built targeting different frameworks. Let's now make sure that .NET 6 is compatible with .NET Framework. So we see that it is not compatible with .NET Core. For that, I just cleaned my .NET Core add-in and rebuilt my .NET 6. So now I'm going to start SOLIDWORKS and check. And indeed, .NET 6 and .NET Frameworks add-ins are loaded alongside each other. So .NET Framework is compatible with .NET 6. Let's now clean our solution to unregister all versions of the add-ins, and I'm going to finalize my video with some bonus section. There are multiple integrated development environments available for you to write your C# and VB.NET code. The most popular ones would be Microsoft Visual Studio, the one I used in this video. Also popular is a Raider from JetBrains, and also there is one called Microsoft Visual Studio Code, which is a lightweight editor. Although there are not that many features available in VS Code compared to Visual Studio, but it still has a compiler and you can debug your code. So let me show you. This is the add-on which we just used in Visual Studio for .NET 6. I'm just going to modify the title to say VS Code so we can see whether it's working or not. I'm just going to use .NET build command to compile that code. And I can use a debugger integrated into Visual Studio as an extension to run and debug my source code. I can also add breakpoints similar to Visual Studio to enhance my debugging experience. So you can see I put the breakpoint on the onConnect method, which is called when my add-on is loaded. So you can see there is a property page created here and the command tab is added in that method. So we see some log output into the debug console and our SOLIDWORKS is loaded. Menu has also been updated according to our changes in VS Code. Let's summarize the video. If using shared DLLs in your SOLIDWORKS add-ins, make sure you strong name those DLLs to avoid version conflicts. It is not required to strong name the add-in DLL itself or any projects which are referenced by this add-in only. It is possible to write SOLIDWORKS add-ins in .NET Core and .NET 6. Furthermore, they will respect the strong naming, allowing you to load two different versions of the same DLL into the same app domain simultaneously. At the same time, .NET Core DLLs and .NET 6 DLLs are loaded into the same application domain, which introduces a version conflict between those DLLs. But I would still recommend using .NET Frameworks to build your SOLIDWORKS add-in until it is officially supported by SOLIDWORKS. You can follow the link in the description of this video to download the sample add-ins used in this demonstration. Thank you for watching this video.